Hello everyone, welcome to today's STEM class. Look, what I have in my hand is a small windmill manufactured through 3D printing. It is not only a model, but also a miniature artwork full of scientific secrets. Windmills can be seen everywhere in our lives. From toys that bring joy to giants that provide us with clean energy, they are all harnessing the same intangible power. So, have you ever thought about why windmills can rotate? What is the secret to its stable standing? Today, let's start from scratch and uncover its mysterious veil. The core secret of windmill rotation lies in the encounter between wind and blades. Wind is flowing air, and when it blows over blades with special angles, it generates a forward-pushing force. To understand this process, let's first introduce several key components of a windmill. These wings are like blades. They are the key to capturing wind power. The middle ring is the pivot, which is like the joint of a windmill, transmitting the rotation of the blades. And this tall body is the tower body. Why do we design it as a hexagon? This is actually a revelation given to us by nature. Look, the honeycomb of bees is a perfect hexagonal structure that can achieve maximum structural strength and stability with minimal materials. In order to make our model more stable, we also designed a stackable disc counterweight at the bottom, which is like putting a colored garment on the windmill. The discs are stacked in order from largest to smallest. Here we refer to the design of a pyramidal structure. Why are many pyramidal structures larger at the base and tapering towards the top? There are two main reasons. First, a larger base means a lower center of gravity for the structure. The lower the center of gravity, the more stable the object, which is a fundamental physical principle. Second, the base uses more material to bear heavy pressure, while the top requires less material. This design avoids material waste and meets structural requirements at the lowest cost. Such structures are widely used in architecture, engineering, and even everyday items, all leveraging their stability and cost-effectiveness. Now is the moment when magic occurs. We are requesting the creation of a miracle tool, a 3D printer. It is transforming the three-dimensional digital models in computers into tangible parts in our hands. 3D printing, also known as additive manufacturing. Its process is like making an extremely delicate 1,000-layer cake. The software first cuts the model into hundreds of thin layers, and then the printer nozzle will accurately extrude the materia according to the pattern of each layer, accumulating layer by layer from bottom to top. Let's do it. Look, these are the just printed blades and tower body. They can't wait to be assembled together. All the parts are ready. The exciting assembly time has arrived. Assembly is very simple. Firstly, assemble the blades and shaft together, then fix the hexagonal prism and chassis, stack the disc counterweight on top, and then fix the top and install the shaft. During the fixing process, we use this small flathead screwdriver to tighten the flathead screwdriver. Its design is simple and effective, allowing our windmill model to maintain a clean appearance and reliable structure. Look, we succeeded! This is not just a manually rotating model, it embodies the wisdom of aerodynamics, structural bionics, and modern manufacturing technology. I hope this small windmill can become a starting point for you to explore the vast world of science. 3D printers create a better life.